In the next video, we'll show you how we can finish off the flatland areas of the internal features. So here, the operation that we've used is triangle mesh flatlands. The machining surfaces have been set, but we've taken the offset off because this is a finishing pass, so we don't need to use that. The tool we're going to use is a 10mm end mill, and under surface paths we need to contain the machining to the area that we want. So if I just show you, these are the sketches here, and if we pick any of these faces, then we can select and right click to create sketches of those faces, and these are a list of the sketches that were produced from that. Okay, so we've got the various sketches there which we can use for the 2D containment of the flatlands finishing. But when we use that 2D containment, we've selected the curves, but we want the tool to go to the center of that shape. So if this is the curve here, the tool will overlap it by the tool radius. If we make it inside, there will be areas which won't be machined. So we set that to center, and we set the minimum step or the maximum step over we want for that tool. Okay, so that searches for the flatlands, and if we switch that on, we can see that it's found the flat area at the top here. It's found the flat area here, and it's also found the flat area at the bottom of that hole. You'll notice how it's avoided these areas here because it doesn't need to machine them. Okay, so that's the flatland machining. Now we can, this is the yellow toolpath here are the rapid movements, and we can control all of these movements via the link menu here. So this is the links, so we can set the retracts here to be the values that we want, and then when the tool is moving between different areas, we can choose to limit the machining so that it doesn't go right out to the clearance plane, it goes out to the rapid distance, and that will mean less fresh air movements. Okay, so we can see we've cut down the amount of rapid movements by changing it from the clearance plane to the rapid plane. Okay, so that's done the flatland areas. So if I switch that off, the next thing we need to consider is the surfaces here, which will be machined with a ball nose tool. So to use that, I've set up a 6mm ball nose tool, and in this case we're using a new calculation based on surfaces, and we're going to choose flow line. What that does is it flows along the longest surface of the part. We pick the drive surfaces, so when we're choosing that, those are the surfaces that are currently chosen. So to choose multiple surfaces, you choose one and then hold down the control key to search for and find and select the other surfaces. But those are all set. Now we need to think about the minimum step over and how it will handle the edge of the surfacing. So here We can merge surfaces if there's a gap in them, and so on. The area, we can play around with different types of surfacing features here, and we'll machine by lanes. So that is now calculating that surface. And if we switch that on, we can see I've set a fairly fine overlap there, or tool step over, so that it will machine out those surfaces there. Okay, so the next thing we'll look at is we need to create this chamfer here for this oval shape. Now I took some dimensions from the drawing, and this chamfer here is a 60 degree. So I created a tool with these parameters. I chose a diameter of 12, the tip diameter of 2, and the tip angle, which is 30 degrees each side, and the flute length is 6. So to create the tool path for the chamfering, there's a couple of methods that I can use, but the simplest method is to use wireframe geometry and a 2-axis profile. Choose the drive curve that you want to machine. In this case it was this one, and then the compensation type here is off, so I want the tool to sit directly on that shape. The heights are controlled by the, oops, I think I've chosen the wrong one there. It's the chamfer oval that I'm interested in, not the other one. Right, so I chose the heights based on taking this information from the model. So I'm cutting round here to the right. And if you want to look at that, so that offsets the tool to machine that chamfer. Then we need to machine the circular slot. Now it's difficult to see from the model, but it looks like it's a single depth there with a chamfer in each corner. So I've defined a chamfer tool and set the tool to be on the profile that I created. So I chose to create the profile. I used the option right click and pick edges, and then you can pick up the individual edges, and then when you're doing that you can create a sketch from that, and then use that sketch as your 2D profile. So going into the circular slot here, I used again wireframe 2-axis profile. The compensation is off so that it sits directly on the profile, and I used a tool which had corner rads on it. So if we have a look at that tool quickly, okay, so it had a diameter of 8, a tip diameter of, a diameter of 10, a tip diameter of 8, and the flute length was 1. So if we have a quick look at that, you can see it's a tool with just a small chamfer in the corners. So that's machined out that slot, and now to machine the chamfer on the outside and the chamfer on there, we chose again by selecting the edges and creating a sketch. We can set the 2D profile, set the tool we want to use, and then the heights. So I've just machined that -2 millimeters and made it into a single slice. So if we have a quick look at that. Now interestingly, you'll notice how it's fed across the gaps here. So to get it to do that, I had to change a couple of the parameters for here. So I said machine by regions rather than by levels, and then minimize the link length. And then under the links tab here, I said for gaps along the cut or between slices, even though there is only one slice, I set it all to direct, so that it starts off in one position, machines all the way around, goes across the gap, and then continues round across the gap, and then when it gets to the end here, then it retracts out. Similarly, I did the same sort of thing here. I just chose the edge there to create a sketch, and then use that for the machining. Okay, so I'll finish that now, and then we'll look at the simulation of the whole part.